Hi guys! Welcome to topic 7. In this topic, we talk all about energy production and climate change. We start off in 7.1 talking about what it means to produce energy politically and different sources of energy, different places that countries can get their energy from. So let's get started. First, by defining what we call energy security. And energy security politically is a significant concern in the global economy today. Energy security is the ability to secure affordable, reliable, and sufficient energy supplies for the needs of your country. And that can depend on a lot of different things. It depends on what's available where you are, the amount of money that you have to put into technology, and what the politics of your energy supply are, and what other countries you're willing to import or export energy supplies to. Let's look a little bit at globally how energy use breaks down right now. So we are still primarily an oil, gas, and fossil fuel economy. You can see in this pie chart of world production, the yellow and the green and the blue are all the different fossil fuels that we still use. Everything else, all the renewable technology available, is in the purple. And by country, the United States and China use a really significant portion of the world's energy. This is the United States in orange, and this is China in red. So you can see that those two countries make up almost half of the world energy needs, which is pretty significant. So it's important to understand what sources of energy are available in the places where a lot of energy is used. Because we are facing what economists call a source crisis. We are not going to have enough supply to meet the rising global demand for energy. Everybody wants more electricity. As a nation becomes more educated, it's something they move towards, not away from. And that fossil fuel-based economy that you saw in the last slide, all of this stuff, that's going to run out. Coal is going to run out in about 230 years. Gas is going to run out in about 170, and oil is going to run out in 100. And if anything, those estimates are generous. So we need to start thinking about where else we are going to be able to get energy from. And there are some case study examples of different ways that people have gotten energy. The first is U.S. shale gas. People also call this, let's get the pen going, people also call U.S. shale gas fracking. And that's short for hydrological fracturing. It's basically when a well is drilled down into the shale rock layer of the lithosphere. And in that shale, there's gas and natural gases trapped between the shale particles. So you drill a well and push down a super pressurized liquid. The liquid makes all sorts of cracks in the shale rock bed, gets out all the natural gas and fossil fuels that are sort of trace supplies in there, and then brings them back when it's drawn back up to the surface to the top of a well so that they can be processed for energy needs. Fracking's gotten a really bad name. It's the layer of shale rock usually sits right below the water table. So if there's ever a problem, natural gas gets into the water table of a community and it can cause things like water that's flammable coming out of people's faucets. It's not a great PR strategy. And it's also not a renewable source of energy. So it's not generally that good of an idea. But as we run out of the fossil fuel economy, one strategy is to sort of fight over the last pieces of that. A lot of other countries are moving towards looking at renewable energy more seriously, and Denmark is an example of a country that's looking at renewables more seriously, specifically wind turbines. Denmark and all the Scandinavian countries are really interested in this problem of climate change as it relates to energy availability, because if you look at all the Scandinavian countries, they sort of like sit up here at the top of Europe, this like Arctic Circle up at the top, and some of them are really just centimeters above the current sea level. So as we see temperature rise, these are the parts of the world that are going to feel the effects of climate change due to unsustainable energy production really significantly. So Denmark has a vested interest in promoting renewable energy, and this wind power they actually sell to the rest of Europe. They don't even use all of it themselves. So that is another way to go when you're looking at diminishing fossil fuel supplies, is to try to find a new source for the world to live off of. And let's look at some of these sources a little bit more carefully. For non-renewable sources, they're all fossil fuel based. We basically have coal and oil and natural gas. All of those things are created from carbon that was laid down in the Carboniferous era, and they were basically fossilized at different temperature. Coal was fossilized into a solid, oil was fossilized into a liquid, and natural gas was kept fossilized as a gas. So there are advantages to these. They're easy to move around in terms of like solid resources. You don't move the energy that's been stored on a grid around. You can actually pick up a pound of coal and move it somewhere else. Same with oil. But all of these are in limited supply. These are non-renewable resources, and we really need to be moving away from them. So what more and more environmental economists are looking towards is renewable sources. And there are so many renewable sources of energy that they don't even all fit here with me in the corner. So let's go over some of them just briefly. Just because something's renewable doesn't mean that it is sustainable and good for the environment. And I think that that is an important point of clarification. Because when we look at hydroelectric power, for example, dams can be really damaging to the environment. So can burning biomass. So can burning wood if you're burning wood at an unsustainable level. Photovoltaic cells, we don't necessarily know the resources that go into these cells, what mining those resources is going to take out of the natural environment. Wind power, you might remember there have been some really bad stories about interfering with bird migration, but generally wind power is pretty sustainable. The big problem with wind power is you need wind, so it's unfortunate if you set up an energy source and then the natural renewable power for that source disappears. Tidal energy is horrible for the environment. You basically build these big turbines on the bottom of the seafloor and you dredge out everything that's natural and living there to put down these huge concrete structures. But people like them because in a land of rising sea levels, they double as land protection. They create a barrier, a sea barrier, in front of vulnerable countries. And geothermal is basically like volcano energy, and that's sustainable, but then you obviously need some kind of volcanic activity in wherever you're trying to produce energy. So this is really popular in areas like New Zealand, but not feasible all over the world. Of these, in my opinion, wind energy is probably our best bet looking forward to renewable energies. Passive solar energy is also good, and that's different than photovoltaic cells. Passive solar energy is just building to allow maximum amounts of light to enter your living space, and then also to allow maximum amounts of solar heat to be trapped in your living space. Burning wood is good if you can burn sustainable wood like bamboo, but you get into a problem because the temperatures that different woods burn at means that they give off different amounts of energy, and bamboo is not like a very energy high wood. So I would go 1, 2, 3 in terms of like our best bets for renewable energy. I really don't like dam construction, but the idea that it creates a water resource is really important, so I'd put that one in as 4. And let's talk a little bit about another power source that's technically non-renewable, but that a lot of people are turning towards as we try to answer this question of what are the energy sources of the future, and that is nuclear power. So nuclear power comes from nuclear fission. Nuclear fission is when you are breaking something apart, and the energy that is stored in the molecules is basically the energy that we use to power electricity in nuclear fission. Sometimes people confuse that with nuclear fusion, which is when you are bringing things together, and that is the power that is created in the sun when hydrogen atoms slam together to create helium atoms. But we do not have the capabilities of doing nuclear fusion in any large-scale way. So for nuclear power, we would be looking at nuclear fission. You break down uranium, which is a radioactive substance, and that generates steam to turn turbines. Nuclear fission is great as long as it's going well, because for a small mass of uranium, you get a tremendous amount of energy. It's cheap to mine, and there's no pollutants produced. But the problem is when something goes wrong. When there's a problem at a nuclear power plant, it releases a lot of this radioactive uranium waste into the surrounding area, and that is, generally speaking, both an environmental and a human disaster. So possible accidents like Chernobyl in the Ukraine, Chernobyl, are scary enough that it kind of talks people out of the thought that this is a good idea. There's also the problem that you need to store all of the nuclear waste somewhere when you're done with the uranium, and nobody really ever wants the nuclear waste stored anywhere close to where they live because it's still radioactive and harmful. The additional problem is that some of the raw materials that are used for nuclear power are also used to make nuclear weapons, because nuclear weapons work the same way. So it's a little bit uncomfortable when certain countries start to talk about plans for nuclear power. And this idea of energy production really is a country-to-country question. So for your homework, if you're following along in the textbook, you should read 302 to 317, and then you are going to do a sort of paper one style text analysis on an article about China's power supplies, and answer the prompt that is here. Discuss and evaluate China's energy policy. So read over the article that's available in your homework worksheet, give that question a try, and I will see you in the review video. See you there.